Everywhere you turn, things are turning around you. Spinning, rotating. Take a look. Imagine how many billions of rotating machines are at work. In factories and homes, on the roads, in the fields, and in the air. We all know that where there's rotation, there's friction, causing wear and tear, breaking shafts and wheels, and wasting resources. But at the same time, creating energy in a variety of ways. So the secret is knowing how to use that friction to your advantage. The way to do that is to know the machines inside and out, and to understand what industry's challenges are now and anticipate what they'll be 10 years from now. As we undergo a new industrial revolution and technology moves ahead at lightning speed, one thing will never change: the need to minimize friction. That's what we've done for more than a century, and what we'll continue to do. It's a never-ending story. Many see a bearing as just a standard machine element, a commodity. But it can be so much more. It's a critical component that is becoming increasingly smarter, able to tell a lot about the condition of a machine. A bearing is dependent on a robust design and on the seals and lubrication surrounding it. Our design was born from a dedication to technology research and development across all industries. That R&D is twofold, covering material science and product development and manufacturing processes and technology. This is what we call application-driven innovation. Understanding that each industry has different needs, each customer its unique demands, is what keep technology leaders in the lead. For instance, wheel bearing units used in millions of cars have completely different demands than aero engine and gearbox bearings used in aerospace. But each of these industries is calling for lightweight products that produce less friction. Product development across SKF is actively working to meet those needs. There is also a call for better predictability of machine performance. Innovative technology like self-powered wireless sensors connected to the bearing can provide instant condition monitoring data from a wind turbine or a train, making predictability a fact. R&D doesn't only happen in the lab. By examining our own manufacturing processes, developing and testing new technologies in our factories, we can take what we have learned and put it into practice. The Industry 4.0 revolution to digitalized and automated factories has already begun at SKF. A task like altering a machine setting that could once take hours is now possible in seconds with smart robotics. A more efficient and flexible factory will help keep costs down while driving performance up. It's that simple. In any industry, maximizing on machine uptime is a must. For process industries like paper mills and mines, unplanned stops are catastrophic. Not just a headache, but a major cost. The same goes for wind and ocean power operators, and their turbines are often situated in remote, harsh environments that demand extra control. Unnecessary extra costs don't only come from breakdowns. Many industries still perform reactive or interval maintenance. But why change a bearing or grease after a year just because the schedule says so? Predictive maintenance is helping industry be smarter and more efficient. That starts with remote monitoring and diagnostics of critical machinery. Vibration, load, temperature, and speed say a lot about a rotating machine. This data can be used to plan maintenance, along with lubrication systems that ensure the right lubricant is provided in the right quantity at the right time. Analytics used in the right way can cut downtime and costs at all types of operations, big and small. This data is not only critical to those who own the rotating machinery, but to all of us who perform the maintenance and design the products inside. By getting the machine in sight, we can work side by side with customers early in the design process to make improvements. Those building trucks for the mining industry need robustness, while those designing and producing agricultural equipment demand availability. And of course, they all expect less friction. Our job as a facilitator is to know which option is best, because the type of function and performance expected from one machine may be drastically different from another. That job is also knowing whether it's best to use a new part when it's time for replacement, or a remanufactured one. The process of rebuilding old spindles, gearboxes, and bearings is so advanced today that often these parts become as good as new or better. Whatever the service or solution, wherever it's offered, however it's used, it's important to know the role it plays in the big picture. There are over 1 billion cars on the roads today. An SKF wheel bearing unit can reduce friction by up to 20% compared to standard units. And transportation is just one sector. If there was just a little less friction and less weight in all we designed and built, imagine the possibilities.
We are truly everywhere.
And that's never going to change.
Because everything around us
will keep turning,
spinning,
rotating.
We are creating a world of reliable rotation.
So our crusade
against friction and weight
continuous.
That work will never be done.
Will never be done.
Will never be done.
It's a never-ending story.